Hello, my name is Yousuf. I am the project lead for FIP, EternaTech, and my team members are for this FIP are Razeen Virani, Sulait Sufiyan, Ismail Naseem, and Abdul Samad Rumi. We try to keep the name short and meaningful by combining two words, eternal and technology, together. Our goal is to make machine eternal using technology. Our data model consisted of four data science models with their own different accuracies. We picked the best of all, which was random forest with the accuracy of 81%. The technology stack that we've used is Flask for our front end, Jupyter and Python for our back end, Fast API for integrating the front end, and Power BI for the dashboard. How the project works is we have a front end which allows the user to send in the data that was pulled in by multiple IoT devices and sensors, which are fitted on our refinery machines in Paraco. All that data is pushed in through our front end, which is integrated with Fast API. The Excel file will then be cleaned, processed, fitted, and then loaded into the trained data model. The prediction will be given out with an accuracy of 81%, and the prediction can be downloaded then. The downloaded file will be parsed into Power BI for dashboarding. Multiple dashboard pages will cover different aspects of the data information. I'll run you through it. The story, then the model specific analysis, and the other pages will focus on engine specific analysis and the remaining useful life. So what basically remaining useful life is, it is basically what the number of days are left for a machine before it runs out of maintenance. And the engine number signifies the number or the specific engine number, which will have its corresponding remaining useful life, which will be predicted through our data science model. This is the dashboard which works for the accuracy of our analytical models. Uh, we've used a slicer over here, and we have our errors over here, the accuracy over here, and this is a custom chatbot for our for a user to inquire about a specific analytical models. This page signifies all the information which is there about our engine, the engine number, the remaining useful life, the speed at which the engine fan is working at, the shaft speed the engine is working at, physical fan speed, and the energy loss. And we also have a custom chatbot for this part of the dashboard too. And upon selecting one, it will reflect all the necessary information related to it. And for the remaining useful life, we have a separate page with all the key influencers mentioned on this part of the screen, and we have every engine number mapped against its remaining useful life. And this table and this push notification option allows us to run alert emails, which will help us get notified without being on the seat. And whenever span or any machine which goes below the span of 14 days, alert email will be run out, and we'll get to know. It can be on our personal phones or anything. It can always be switched. This is what our code is. We have this is our front end, and these are our database models over here. These are all our database models, and all the fitting and the correlations is all present in this code over here. I'll show you the front end. This is a front end. Over here, we'll upload a file. And as soon as we upload a file, I think I'll have to run the code again. Once the code is up and running, we can connect it to Fast API, and Fast API will enable us to connect with our front end. Our Fast API is up. Now we have our predictions ready to be downloaded. When we download a file, we can parse it into our dashboard and will automatically set to this new data. This is the workflow for our whole program. We perform the data collection. The data is loaded into Excel. The Excel is then cleaned, fitted according to our data model integrations. And then after inspection and analysis, we have a workable data. We have a workable file with us. We can run it through all the four models that we have: the support vector machine, k-nearest neighbor, random forest, and linear regression. But we've used random forest obviously because of its highest accuracy. And once the predicted data is given out, we train it to you and reflect it on a dashboard. So that is from our whole project. I can show you this feature of running out alert emails. I've pressed the trigger button and I can then log in again. Sorry for the delay. I was checking the wrong account. So here it runs out an email saying, "Hi team, engine number 25 is about to break down in 9 days. I told you that we have a threshold of 14 days, and any number of any engine which goes below the 14-day mark, it runs out an email and it is giving me the important stats along with it, referring to its shaft speed, the engine energy loss, and the physical fan speed. And it just gives the prompt that you need to schedule the whole maintenance process for it. So this is what our whole FIP was, and thank you.